alphabetically. And they are a three-folder, last name A to I, J to Q, and R to Z. So if yours is not on that folder, pass it down. At the same time, I'm giving you another quiz today in the middle of the lecture. And I will have this FaceTime, so don't look at it until I ask you to. It's a relatively simple quiz. No preparation needed, 5 minutes, maybe I give you 10. So the agenda today is just to go over the quiz from last time, and then answer any questions you have on the homework due today. It's not collected because we're going to have a quiz. And those are 3 problems. I think the first one on this wind tunnel one is what I want to spend the time on. And if the question on the others, I'll be happy to answer it. And after that, I spend maybe 10 minutes on what we have done since the lecture of day 1 until now as a review. Nothing new, just a big picture recap. And then I'm going to have the quiz. So the quiz should be relatively simple. And something that should be done the first lecture, I wait until now, is a very kind of lighter side of intro to fluid, just to see what are the questions we can answer by studying fluid mechanics in everyday life application, and the roadmap of what we would do for the rest of the semester. And then after that, I want to spend the last 20 minutes of the lecture or so to answer the question, where does Bernoulli equation come from? And that has to do with something called the Euler's equation. And that will be sufficient for today. And that is all the preparation we needed for test 1. For that, tonight, not from 7 to 8, I couldn't get a classroom, period. So I have to change it to 8 to 9. You will be next door, not in this room, for what I call a help session or study session. Let me emphasize, if you're on top of the material, don't waste time coming in. It's absolutely a waste of your time. Only if you have questions on the homework, on the reading, on the quizzes, then you may want to come in and ask questions. It's informal, no lecture. I just make myself available for any question. And I have asked Mike to set up additional office hours tomorrow before the test. Yeah, during the day, in case if you have a last minute type clarification that you want to have answered. So the test is not in this room. Please listen carefully. It's next door. Tomorrow from 7 to 8:15. Any questions on the test? Again, half a page of formula sheet. You're welcome to bring your book, and if you think you need to use it, raise your hand and ask for permission. Any other question, comment on the test? Oh, yes? I'm sorry? Yes, you got your own formula sheet, yes. Half a page, yes.
We want the constants on there?
You can put anything you like. It will not be looked at, it will not be collected. It's all for you to keep. And at the end of the semester, you should have 1 page, front and back, for the entire semester. Because test 2, you'll be allowed to use the second half of the first page. And on the final, you're allowed to use the back of the same sheet of paper. So you have front and back for test 1, test 2, and the final. Is that clear? Other questions? Yes?
So you said half the page?
Uh-huh.
So half the front page?
Mm-hmm.
Okay.
So here's 1 page. Half a page will be just like this. You can put down anything you like. Test 2, the full first page. Final exam, front and back. You just build on it for each test and the final. Any other questions before I try to tighten up all the loose ends to prepare you for the test? So this is a relatively simple quiz. I hope you've done well. What does this square bracket mean? I introduced that last time. The square bracket. When I say a square bracket, what am I implying? Anyone? Yes? I'm only interested in the unit, the dimension of this quantity called momentum flux. So we'll be using that a lot more later in the semester. So I'd like you to get used to it. This Fn is my nomenclature to mean a function of. So the quiz first part is express this quantity mass dot, which is or m dot or mass flow rate times a velocity as a function of the 3 fundamental units in mechanical engineering, which is mass, length, and time. So that is straightforward, take you no time. And that's the answer to part A. Part B is that I have a 5 foot diameter, 5 foot per second water jet, and I like to calculate on that basis what is the momentum flux due to this so-called flow. Is flow VA, whereas the momentum flux is flow U. Is flow U square A. So that's something you have seen many times over. So calculate that for me in the English unit for a jet of 5 foot per second. Density is given. Velocity raised to the second power. And the diameter is, you were told, is 1 foot, which is pi diameter squared divided by 4. And that is according to my calculation of momentum flux. What do you expect the answer to be in the problem statement in terms of the units? The problem statement we give answer in terms of pound force. This has the unit of pound force. What am I missing? G sub C. If you do all that, the momentum flux due to this water jet is about 40 pound force. So mainly the real reason of doing this quiz right before the test is for me to make sure all of you, if not at least most of you, understand the use of the G sub C. Is that clear? Any question on this? All square? Okay, very good. So, walk in the park for this quiz then. Homework, 51. Question on the use of manometer. Do you understand the concept of jump line? For those who have 21, 24. You may have this in a different context, but the concept is the same. You have to know how to deal with a manometer. So for this case, the pressure above my manometer here is the same as that in the center of the wind tunnel, which is what you asked. This is air, so what is the pressure here at P2 compared to the pressure on top of the manometer?
They're the same.
They're the same. Can you see that? Why don't I have to account for this column of air for this certain height, which is not known? What is the pressure between my foot and the ceiling? Same, 14.7. Why is that? If this is a column of water, swimming pool, 15 feet. Density is a lot higher for water. So for air, the density is so small, this is the same pressure. Right? Do you see that? So get used to it. The manometer consists of oil on the right-hand side of the column. I call this the right-hand side of my manometer. This is a little bit of repeat of 21, 24 again. The left-hand side is all consists of water. SG, you know how to deal with that? What does SG stand for? Very good, okay? Reference to water. Okay, so the jump line tells you that the pressure between these two stations are the same. So P2 plus rho GH, this is the left-hand column, P2, the pressure in my tunnel, times rho GH of all for water, must be the same as the pressure across the jump line. I'm moving from pressure on the left-hand side to the pressure on the right-hand side. And the right-hand side is volume of water times an inch. The H here is in feet. Do you see that? Any question? If you have done it, this is just a repeat. Maybe I'll do it more logically and systematically. Any question, please? So manometer is a must. No question? So this P2 here, as expressed by my equation, is it in absolute or in gauge? Can you see that? Very good, it's in gauge. Why? Because I didn't include the other pressure on top of the manometer, which is what? Atmospheric, very good. So I hope you're all on top. Right? So in the Bernoulli equation, when you use Bernoulli, P1 plus half rho V1 squared plus rho GC. What pressure should this be? Absolute or gauge? Does it matter? No, as long as you're consistent. If you use gauge on the left, use gauge on the right. If you use absolute, then use absolute. It's all a delta, right? So manometer, I thought I'd just touch on that to make sure you understand how to deal with it. This tunnel pull air in from the ambient. Can you see based on the physics of P plus half rho V squared that immediately your conclusion is the pressure at 2 is a vacuum? Can you see that? No? Okay, let's go through that. Far away from the tunnel, I told you as a hinge. I go a mile from the tunnel. This is a suction tunnel with a fan in the back, drawing air in from the ambient. If I stay far, far away from the tunnel, a mile, 10 miles, what's the velocity of the air and the pressure? Zero velocity, or we call it approximate zero. Pressure without ambient. P plus half rho V squared is a constant. Put 2 here. And this constant, if I go far away, is P atmospheric, 14.7. Far away, this is 0. The constant is 14.7. Velocity is 60 miles per hour. These two add to be a constant. This P2 must be negative. Must be a vacuum. Do you see that now? Okay, that's typical of wind tunnel, including the one we have right next to Randolph. You pull air in the tunnel at 150 miles per hour, hurricane category 5 speed. The tunnel is a vacuum. You walk in there, your ear will pop. Just like on the airplane. Yes?
What was the velocity at 0.30?
Okay, so 0.3 is where the flow entered the tunnel. You hit the nose of the hood. When it hit the nose, where does it go? Nowhere. Just like the pedal tube. It hit, I'm running at 60 miles an hour towards that wall. What do you think will happen to me when I hit the wall? I stop. I'm not going to go through the wall. Right? So the velocity by definition at V3 is stagnant. So what is the pressure here if it's stagnant? What's the answer to part 2? You come in at 14.7 with velocity negligible, you go through all this acceleration at 60 miles per hour, and you draw a vacuum here at P2, hence the manometer is drawn as it is. So when you look at the manometer, can you see the fact the pressure at 2 is less than ambient, right? And then I continue on until I hit the nose, and I stop at 0 velocity. What pressure do I have at this point? 14.7, same as I started. It's a trick question, but it's nothing but Bernoulli. So I thought it's worth to just walk you through this. Yes?
You said that last right?
Which part?
When you said the pressure, 0.3.
Okay, so let's walk through the whole streamline when I start from far away from the tunnel, where I don't even feel the suction of being pulled in the tunnel, right? So I'm a mile away from this tunnel, what pressure and velocity am I at? Pressure, 14.7, velocity, 0. Now I get closer and closer and I feel the flow accelerating. And once I'm in the tunnel, continuity dictates that I must go at the same speed, which is 60 miles per hour everywhere. So along this streamline, I'm 60 miles per hour right here. And at 60 miles per hour, the pressure in the tunnel must be sub-atmospheric or a vacuum. Why? Because the maximum pressure is ambient, where the velocity is 0. When I'm at finite velocity, this pressure must be less than atmospheric. So the sum of P plus rho v squared half is equal to 14.7. So I must now experience the vacuum in the tunnel, hence the manometer is what it is. I continue on until I bam, hit the wall, and have nowhere to go. I stop from 60 miles per hour to 0 miles per hour right here at this point. What the pressure has to be when that happens. I go back to atmospheric. Right? The velocity is 0 for a different reason. Because I hit a wall. Just like when the flow entered my pitot tube. I have nowhere to go. The pitot tube reached what we call the total pressure. So in this case, it happened the total pressure, or stagnation pressure, is ambient, 14.7. Okay? Now, rather peculiar, not the typical case, but you can add all the physics up. Yes?
So when we do Bernoulli's on test, should we draw our streamline that we're referring to?
That is a very good practice, yes. Yeah, so that I know what is the start point and what is the end point. Yeah, very well said. Okay, other questions on this problem? Yes?
You put the manometer under the column at point 3 where the H is 0.
If you put the manometer right at this, if you put a pressure gauge right at this point, you start manometer with just a pressure gauge, what would that read? What would that read? Well, that's a question for your part 3. What would that pressure gauge read? Say that again? P2? No, P2 is here. P2 is 60 miles per hour. If I put a manometer, this is what I did, I put a manometer here or pressure gauge, I will read the pressure that is calculated for this part, which is happen to be. So pressure at 2, as you will see the solution being posted today, is negative. Pound force per square foot, it turns out to be a very small vacuum, very tiny vacuum, only about 0.06 psi, but enough to hurt your ear that you can feel it, right? So going back, maybe I should change this diagram. Instead of the nose of the car decelerating the flow, I replace that with the pitot tube, which is the same phenomenon, namely the flow going in and it stops, stagnant. What will be the reading of this pitot tube? 14.7. 14.7. Same as where I started, because the velocity there is also negligible. 14.7 is very peculiar, but you better believe in Bernoulli. It's counterintuitive because the P2 and the pressure is a vacuum, but they all add up. They're all physical. Does that help? There was another question?
I'm just confused as to why the velocity stopped at the roller cars and just going around the
Some are full, so we're going to talk about something called streamline momentarily. What you, intuition tells you is correct. So I have a car here. there's always one streamline, and that's the one that the question asked you. There's always one streamline that will hit the car and stop. There are others that will go around. Okay, those patterns that I sketched is what momentarily what we call the streamline in the Bernoulli equation. So you see a TV commercial of an automobile being cast in the wind tunnel, and they put some smoke in front of the car, and the smoke go around the automobile. So those streamline, what you're referring to, they bypass. That's the nation point. But the one we asked right now in the problem statement is there's always one streamline that will hit the hood and stop. And that's the one we want to analyze. And the physics is equivalent to me 60 miles per hour running towards the wall and stop above it. Right? And then the other streamline that may diverge and go out of direction, but that's not the one we are asking. Right? Questions? I mean, this phenomenon is the same with an airplane cutting through air. I mean, so an airplane flying through air, with the wing and all of that, always have one streamline that hit the plane and stop. And then there are others that go around. Like this. So I introduce some smoke in front of the airplane and watch how they go around the airplane. Those are what we call streamline. And then there's always one that happens to terminate or stop on the airplane. That's what we call the stagnation streamline. Okay? There were other questions on this problem? All set? Clear? You understand why the tunnel is in vacuum? Very good. Any other question on the other two problem? The nozzle with XY forces. That's, I mean, I'm not telling you anything new. That is a must for test one. You got to know how to do those problems. Questions?
For the T problem?
Yep.
For Bernoulli, when you try to solve for the pressure inside the pipe,
Yes.
you just choose one of the exits for your
Yes.
second point?
Correct. Pick one. Anyone.